Okay, so I lied. We are going to do one more example, and we are still doing the increasing and decreasing, which is also known as the first derivative test. That's what we're actually doing, because we are taking the first derivative, and our directions are going to find the relative extrema, okay? So I am going to take that first derivative, and we got a chain rule right here, so we got to do 2/3 times, keep it in the middle, and decrease that power by 1, so minus 3 over 3 is negative 1/3, and I do have to take the derivative of the inside, which is 2x. So now I'm going to clean all that up because that just looks really bad. I'm going to get the derivative equals 4x over 3 times x squared minus 4 to the 1/3. Okay. Now that I've found my first derivative, I need to set it equal to 0 to find those critical numbers. And remember, that's where like it's changing. So I'm going to say 4x over all of this equals 0. I'm going to multiply by 3 to both sides. And so now I have 4x. I'm going to go ahead and take this back up to the top, okay? Times x squared minus 4 to the negative 1/3 equals 0. And so now I see that I can do what? I can divide both sides by 4x. Because I see that thing's kind of the weird thing that's making me question it. And I can get x squared minus 4 to the negative 1/3 equals 0. And I didn't, not that. I have 4x times x squared minus 4 to the negative 1/3 equals 0. I'm going to separate them. So I'm going to get 4x equals 0, and I'm going to get x squared minus 4 to the negative 1/3 equals 0. Sorry. I get x equals 0, so that is a critical point, a critical number. And then I'm actually going to take this to the negative 3 over 1. If you remember, like rules of exponents, you want to cancel those so that it zeroes out. And if I do it to one side, I do it to the other. So I'm going to raise that to the negative 3 over 1. And so I actually get x squared minus 4 equals 0. Okay, then I'm going to factor it. And I'm going to get x plus 2, x minus 2 equals 0. So I get critical numbers of negative 2 and 2. So this time, I actually have 3 critical numbers, and that is totally okay. Remember, I couldn't do that because I had a variable there. So I had to separate it into 2, and that's totally fine. So this time, I'm going to have 3 different positions on my chart. So my lowest critical number is negative 2. And then my next one is 0. And then this is about to get hard. I get 2. I can't keep this steady. So I'm actually going to stop the video. Actually, I'm going to try. Can you come help me? I'm videoing. Come here. I need you to hold the paper right. No, for real. Just hold it still so it doesn't move. Just hold it still right there. So I've got to plug in numbers that are on each side of this. No, for real. And I've got negative 3 because that's a number smaller, and I'm going to plug in negative 1. I'm going to plug in 1, and I'm going to plug in 3. Just put your hand right there. Yeah. So when I do that, remember I'm going into the first derivative because I already found my critical numbers, and so I'm going to say f prime of negative 3 equals, and I'm not actually going to do this because I've already done this, but when you sub in negative 3 into this derivative, you get a negative number, and so that means it is decreasing. Okay, so when I say f prime of negative 1, you get a positive number, and so you're going to be increasing. Remember, we don't actually care about the actual number you get, we care about the sign. When I say f prime of 1, I get a negative number, so that will be decreasing, and f prime of 3 does give me another positive number. So I just have to clean it up when I write it, and I'm going to get increasing on the intervals between negative 2 and 0, and 2 to infinity, and I get decreasing between negative infinity and negative 2 and 0 and 2. So if you need to go ahead and screenshot that, take a picture of it. Remember, we sub this in to our derivative. You just sub it in. We got these numbers from solving for 0. And if you wanted to find the relative max and relative min, you take critical numbers into original. Okay, here we go. All right.